Dear student, today I will tell you the architecture of 8259 programmable interrupt controller. In the last lecture we have covered the basic need why we require this 8259 chip. Okay, so 8259 increases the number of interrupts for microprocessor. Okay, so here the device will interrupt to the 8259 and then 8259 will interrupt the microprocessor, and then if processor is interested to service that interrupt, then it will send the INTA bar to ask the ISR address. Okay, so this was the basic concept. Okay, the need why this chip is needed I have explained in the last lecture. Now I will explain you the architecture of this 8259. So see here, the devices which interrupt the 8259 are connected over here. Okay, so these are the pins where the devices are connected, and this is the interrupt request register. So this registers are for storage. Okay, storage purpose. So this register have some bits. Okay, 8 bits. So whichever pin is giving the signal 1, that bit will become 1. Okay, suppose this IR1, the device connected at IR1 is giving the interrupt. Okay, so this pin will earlier this pin was 0, suppose, so this bit was also 0. Okay, so when this pin gives the interrupt, this pin become 1. Okay, so this bit will also become 1. Okay, corresponding bit also become 1, and after giving the interrupt, suppose this pin becomes 0. Okay, so this this bit will not become 0, this bit will remain 1. If you remember, in the interrupt lecture we have used that D flip flop. Okay, so once interrupt has occurred, this D output of that D flip flop will become 1. Okay, but if the interrupt has gone, that output of D flip flop remains 1. Till then the interrupt is serviced. Okay, so this the bits corresponding to these pins will be at this interrupt request register. Okay, so if this interrupt has occurred, this pin is 0. If this pin is 0, the bit is 0, but if this pin is 1, the bit becomes 1, and if this pin becomes 0, this will remain 1 until the interrupt is serviced. Okay, so this is the use of this interrupt request register. Why this interrupt request register is in the scenario? Because of this reason, that once the interrupt has occurred and it has gone, this bit will remain 1, keep reminding this priority resolver that I am pending, so I am in the waiting of serviced. Okay, this priority resolver here, all the test for this interrupts has happened, and based on this checks, this priority resolver take the decision to send that interrupt to the MUP. Okay, so this was the first check, that interrupt, when this 8259 will send the interrupt to the MUP when the interrupt occurs. Okay, so this is the first check where the interrupt is occurring. Okay, the next check, interrupt mask register. Okay, interrupt mask register is again having 8 bit. Okay, so we can say that in the earlier lecture I told you that 8259 has the facility that it can individually mask the interrupts. Okay, so here it is an 8 bit register where all the pin corresponding to these pins are in those 8 bits, and if any of the register is masked, then that corresponding pin will be 1. Okay, suppose IR1 has occurred, has interrupted the device, but MUP is not interested to service that IR1, so it will put a masking bit. Okay, so it will mask the IR1, and after receiving the interrupt from here, from the device, this priority resolver check the status of mask and unmask. Okay, so if IR1 has given the request but it is masked by the MUP, then it will be discarded. It will not be pending, it will be discarded. Okay, so this is the use of interrupt mask register. Once the device has given the interrupt through any pin, suppose IR4, a device has interrupted through IR4, and if IR4 is masked by the MUP, then this priority resolver will check the IR4 pin, and if it is masked, then that IR4 will be discarded. Okay, so this check will be for the masking purpose. Okay, and once if all the interrupts are unmasked, then only this check will be okay. Okay, so and the third check, in service register. This is the in service register. This is again having 8 bits corresponding to this IR0, IR1. Okay, so IR0, 1, 2, 3, 4, 5, 6, 7. Okay, so this register will tell that which interrupt is being serviced. Okay, this will tell the status of the interrupt which is being serviced. Okay, once if IR0 has occurred and it is being serviced by the processor, so if IR2 has occurred, which is the lowest priority of IR0 from IR0, then that interrupt will not be sent to processor, because this highest priority interrupt will be serviced first, and then the turn of lowest priority interrupt will come. Okay, so this is the working of this priority resolver. It will first check the interrupt request register. If any of the interrupt has requested, then it will go for checking the interrupt mask register. If that particular interrupt is not masked, then only it will check the interrupt in service register. If that particular interrupt is masked, then that interrupt is discarded from this IRR. Okay, now suppose we see that multiple pins on this interrupt request register can be one, because suppose 4 to 5 devices are given the interrupt at the same time, so multiple bit can be one. In this interrupt mask register, multiple bits can be one, because suppose MUP is not interested in servicing this IR2, IR3 and IR4, so it will give the mask to these service these registers. Okay, so multiple bits can be one in this register also, and in this register also multiple bits can be one. How that multiple bits can be one? Suppose I give you an example. Suppose interrupt IR5, interrupt 5 is has occurred. Okay, it is unmasked. First test it has cleared, it is unmasked. The second test it has cleared. Now no other interrupt is in service, so IR5 will be serviced, so that pin is 1. Okay, now when this interrupt is being serviced, how that interrupt is being serviced? This is a call instruction where we go for the ISR, and then this ISR will run, and then will come over here. Okay, but during this ISR, suppose this ISR of IR5, okay, interrupt is going on. During this ISR, suppose IR2 has occurred. Okay, so IR2 has occurred means the interrupt has occurred. IR2 is unmasked, so this test is also okay. Now see here, IR5 is going on. This in ISR for IR5 was going on. That's why this bit is 1, because it keep the record of which ISR related to which interrupt is going on. Okay, so here it is 1 means IR5 is going on. ISR for IR5 is going on. Now which interrupt had occurred? IR2. When it has occurred? During the ISR of IR5. This is the ISR. Okay, ISR of IR5. During this ISR, this IR2 has occurred. So when this has occurred, this in service register will tell us that this ISR is going on, but as this is of the highest priority, okay, this IR5 is of lesser priority than IR2, then IR2 will be serviced first, and this will be pending. Okay, this will be serviced and this will be pending. Once the ISR of this IR2 is completed, how it will be serviced? It will be serviced like nested int ISR. Okay, so this will go to the ISR of IR2, it will be finished, then it will resume to the ISR of IR5. Okay, so first this will be finished, then this bit will become 0, and then this will be resume, and after completing of this, the MUP tells the 8259 that okay, I have completed all the ISR. Okay, so did you get this point? That if this register can also have the multiple bits 1. Okay, now see the example. If suppose ISR of IR5 is going on, okay, and 2 and 7 has occurred. Okay, ISR of IR5 is going on and 2 and 7 has occurred. Interrupt 2 and 7 has occurred, and suppose interrupt 2 is masked. Okay, suppose interrupt 2 IR 2 is masked. Masked means this bit is 1. Okay, so now what will happen? First interrupt 2 and interrupt 7 has occurred. Okay, these corresponding bit becomes 1. Okay, now priority resolver check the interrupt mask register. So IR2 is masked. IR2 is of highest priority than IR5, but IR2 is masked, so immediately this interrupt will be discarded because MUP is not interested to take this interrupt at this time. Okay, so this IR2 is discarded. Now IR7, no mask for IR7, so IR7 has cleared this test also. But in the in-service register, this priority reservoir will check that ISR for IR5 is running. So IR7 is now a pending interrupt. Okay, because highest priority for from this IR7, which is IR5, its ISR is running right now. Okay, so this will become the pending interrupt. IR2, why IR2 is discarded? Because in interrupt mask register, when this priority resolver checks the interrupt mask register, the IR2 it found that IR2 is a masked interrupt. So MUP is not interested to service the IR2 right now. That's why this interrupt is completely discarded. Okay, and this interrupt is pending interrupt because it is a lower priority than IR5 whose ISR is being serviced right now. Okay, meanwhile this IR3 has occurred. Okay, suppose that IR3 has occurred, so now MUP, sorry, this priority resolver will check that okay, IR3 has requested, then it will check the interrupt mask register. So it found that no, there is no masking for IR3, and now it see here in service register is in service register tells that ISR for IR5 is running. So it will give the hold to this ISR, and then it will go for running the ISR for IR3. Okay, and then after completing this ISR, okay, when this pin will become 0, this ISR will resume again. Okay, so this is the basic mechanism of this this 8259 chip. One more thing I want to tell, that a interrupt cannot interrupt itself. Okay, suppose the ISR of interrupt 5 is running. Okay, and interrupt 5 has occurred. Suppose ISR of interrupt 5 is running, now interrupt 0 has occurred and no interrupts are masked. Okay, it means interrupt 0 will be serviced, interrupt 1 has occurred, then it will be serviced. Suppose interrupt 2 has occurred, 3 has occurred, 4 has occurred, then all the higher priority than IR5 will be serviced first. Okay, but if IR6 has occurred, then it will be considered as pending interrupt. IR7 has occurred, it will be considered also as pending interrupt. Okay, but suppose if IR5 has occurred while ISR for IR5 is being serviced, is being running in the running position, and IR5 has occurred. So suppose ISR for IR5 is being serviced. Okay, it is running. Okay, this is the main program, and here we have called, and this ISR is being running. Okay, so this is the ISR for IR5. Okay, now at this somewhere at this middle of this ISR, the IR5 has again interrupted. So what does MUP do? MUP will suspend this ISR and go again to this ISR. It means what is happening, बार बार अगर ये मिडिल में आता रहेगा और ये IR5 इंटरप्ट करता रहेगा, तो ऐसा नहीं है कि म्यूपी बार बार इस ISR पे जाएगा और रन करेगा, अदरवाइज दिस विल बिकम एन इनफाइनाइट लूप. ओके, सो what is mean, interrupt cannot interrupt itself. Okay, so once the ISR of IR5 is going on, then IR5 cannot interrupt itself. Okay, so this is the main point. And once if the MUP will finish this ISR of IR5, suppose ISR of IR5 was in going on, and once it has MUP has finished the ISR, then it will release the EOI command, means end of interrupt. It will send this command to the 8259, and then 8259 will put this status 0. Okay, so this is